Hello and welcome to our demonstration of the IROPS Agentic framework built on mcube. Airline operations are incredibly complex, and disruptions can quickly cascade across the entire network. Our framework addresses this through a collaboration of agents, including the IROPS Predictor, the Communicator, and the Optimizer agent, working together to predict disruptions early, coordinate responses, and optimize recovery decisions. The first component in this framework is the predictor agent. We'll also show you the interface for this shortly. The predictor agent estimates the probability of operational disruptions. It continuously analyzes multiple data sources such as cars, NOTAMs, weather data, and other operational and real-time inputs. The system applies predictive models to calculate a disruption probability score. Once a potential disruption is detected, the communicator agent is triggered to deliver timely and personalized updates to passengers across relevant channels, keeping travelers informed about delays, cancellations, or recovery options. This helps reduce congestion at service counters, minimize uncertainty, and significantly improve passenger satisfaction. In the demo later, we'll show how these automated communications are triggered and delivered in real time. The third component is the hybrid optimizer agent, which works closely with the predictor agent to enable integrated disruption recovery. This agent simultaneously evaluates multiple operational factors, including aircraft availability, crew scheduling, and passenger recovery, to determine the most effective recovery strategy. It uses a set of specialized optimization solvers that collaborate within the agentic framework, allowing the system to analyze complex trade-offs across the network. Based on the airline's priorities, whether that is minimizing operational costs, maximizing passenger satisfaction, or balancing both, the optimizer generates a viable recovery plan. Importantly, the system looks several days ahead, ensuring resources are distributed intelligently and preventing bottlenecks across the recovery timeline during major IROPS situations. If we look at the overall architecture, the system operates across three layers. 1. A real-time data layer, ingesting operational inputs from multiple sources. 2. An intelligence layer, where predictive models and optimization engines analyze the situation. 3. An action and integration layer, where agents trigger communications and recovery decisions. Now let's see the platform in action. Here you can see the mcube interface showing the network overview dashboard. For this demo, we've simulated a scenario around November 8th, representing a severe snowstorm affecting flight operations. You will notice several aircraft indicators on the map, some highlighted in yellow and others in red, indicating different levels of disruption risk. From here, we can also change the date to analyze different scenarios. The dashboard shows key metrics such as the number of active flights, average delays, disruption probability scores, the number of flights with probability scores above 70, and the cancellations recorded so far. I can also switch to the station view for different airports. You can see that JFK is not significantly impacted, but if we look at ORD, you'll notice quite a few flights showing very high disruption probability scores. Once disruptions are detected, the system proactively engages with passengers to keep them informed and supported. This is where the communicator agent plays a critical role. In this view, you can see that a thunderstorm is impacting operations at ORD, affecting 47 flights. The dashboard shows how many warnings and notifications have been sent to passengers, as well as the rebooking and rescheduling offers issued to help them adjust their travel plans. It also tracks how many of these offers have been accepted, giving operations teams clear visibility into the overall resolution rate and effectiveness of the recovery process. The next step is the Outreach Composer. Here we return to the same operational scenario and select a specific flight to review the disruption in more detail. In this case, the system shows a delay of approximately 40 minutes, along with the underlying reason for the delay. From here, we can generate a draft communication for passengers. At this point, the LLM engine is triggered, which automatically composes messages tailored to the situation. Based on different passenger profiles and travel contexts, the system generates personalized and context-aware communications. To ensure PII compliance, we are only displaying clusters of passengers rather than individual customer identities. However, in a real operational environment, this entire pipeline can be configured to generate and deliver fully personalized communications for each individual passenger rather than sending a single message to a customer segment. This allows airlines to scale highly personalized passenger engagement, ultimately improving the overall disruption management experience. With that, we conclude the overview of the IROPS Agentic framework